Well, here is one more problem at your screen. And there is a circular cone with half angle alpha. This angle is alpha. And this angle is also alpha. Half angle alpha equals 30 degree and the base radius r. That is base radius r equals 5 centimeter. Rolls uniformly without slipping along a horizontal plane. It's a case of pure rolling. As shown in figure, the apex of the cone is pivotally fixed at point O. Where is point O? Achha, here this is. Which is at the same level as point C. The center of the base of the cone. The center of the base of the cone. Okay, C is the center of the base of the cone. I can see that. The velocity of point C is V equals 10 centimeter per second. Find the moduluses of, that means magnitudes of, the angular velocity of the cone and the angular acceleration of the cone. This is one more question. And I hope what we mean by pure rotation and or rotation without slipping, rolling without slipping. Things roll in this world. So rolling without slipping, that is pure rolling. इसका सिंपल सा मतलब होता है कि ये जो पॉइंट ऑफ कांटेक्ट है, the point of contact of the rolling body should not slip with respect to the surface beneath it. So if the center of the I can say here, if the here it is the center of this rolling body. You may imagine anything, a disc or a ring or a cylinder. I like cylinders, or a sphere or something like that, or a hexagon. Hexagon can't do it. It can keep tipping, toppling, but not rolling exactly. If it's one of those things that can roll, and it's roll on a horizontal surface, so its velocity is v. So the point of contact, if things roll in this way, the point of contact keeps changing with time. If there is some point P of the rolling body is at this moment, there will be some point else Q after some time. So these points keep changing always. But whatever point in contact with the surface on which the body is rolling, if the point of the rolling body in contact, I am assuming one point contact in ideal condition, is in contact with the surface on which it is rolling, should be at rest if there is no slipping. क्योंकि स्लिपिंग होगी तो ये पॉइंट स्लिप करेगा ही, अदरवाइज स्लिपिंग नहीं होने का सिंपल सा मतलब रोल कर रहा है वो तो मेरी समझ में आ रहा है. बट इफ इट इज नॉट स्लिपिंग, दैट मीन्स द पॉइंट इन कॉन्टैक्ट with the surface beneath is at rest at the moment it comes in touch with the surface, so it will not slip. तो इसकी velocity, ये point P जो है, ये point P is the basically the point on the surface of this rolling body. So this point P velocity with respect to ground should be equal to 0. Put an observer at the center C, and it will only see the rotation of this body, and the body is suppose that rotating in this manner, supporting its linear velocity of the center. So this observer sitting at the center will be blind enough to not see any velocity v of the center. It can only see point P is moving in this direction. With if the radius of this rolling thing is r, then it will only see the point P is moving in this way. But this is the velocity of point P as seen by the observer sitting at the center, and we can use the principle of superposition again, that velocity of point P will be written as velocity of point P with respect to C plus velocity of C. You can say this is 0, so that velocity of point P with respect to C and velocity of C should have equal magnitude. And in opposite direction, that means velocity of point P with respect to C, omega r should be equal to V. This must be, otherwise you don't have a chance. So that means, and it looks velocity of P with respect to C, the value is omega r here, plus velocity of point C is in this direction, its value is V. So it must have same magnitude and opposite in direction. So you can say here, if you know in rolling bodies, if you know the velocity of its center at a moment, then you will definitely know that every point on the circumference of the rolling body which can come into the contact with the surfaces while rolling will have angular velocity omega equal to V by r. Because here you can see here V by r. So, or the linear velocity of a point on the circumference of this rolling body with respect to an observer at the center is equal to the velocity of the center with respect to ground itself. They say blah blah big thing, so I don't like to write something like that. Leave it now. You must have known these such things. If don't, this is not a big thing. You can think over and you will do it. So here, where is the cone? Here is the cone. You can say cone is involved in two kinds of rotation simultaneously. The first one is rotation about a vertical axis, because this thing is rotating like this in a horizontal plane, so it must be about an axis, about a vertical axis, and it's rotating in anti-clockwise manner, so its angular velocity must be towards us, that means in upward direction, out of the plane of the paper. So in the cone, what I told earlier, the cone is involved in two kinds of rotation. The first rotation is around a vertical axis about constant angular velocity omega 1. This is absolutely constant. Magnitude, direction, all things are constant. Angular velocity omega 1. And second thing is rotating about this axis. Rotating about this axis, because it is basically a kind of a spin. You can see here, it's a kind of a spin. This is rotating in this manner, about this axis. It is a kind of spin. You can imagine things. If you can see it as a spin, that will be helpful. It is spinning about the axis passing through its center, and this is basically not the spin. That is some kind of orbital motion, in which its center is orbiting about a vertical axis in a horizontal plane. So this omega 1 is caused by it's orbiting about a vertical axis, because its center is orbiting about a vertical axis in a horizontal plane. So this is caused by the orbital motion, and this is caused by the spin. So it is involved in two kinds of angular velocities. For me, there are two vectors involved. So I would like to think what was asked in this problem. The angular velocity of the the angular velocity of the cone. So these are vectors. So I can use the principle of superposition. I can write the angular velocity of the cone is simply omega 1 plus omega 2. And you can, do you know the magnitude of omega? This omega 1 and omega 2 both are perpendicular to each other. So its magnitude you would like to write like this. And what is this omega 1 itself and omega 2 itself? We need to find it, the omega of the angular velocity of the cone we got. We will do something like that. But there is a problem that what is the value of omega 1 and omega 2 itself. So omega 1 was due to the orbital motion in a horizontal plane of this center. What was its radius exactly? I don't know. The radius should be this, and this is the radius of the cone, and this angle is alpha. So perpendicular we know, and base we would like to know. Tan alpha, what is tan alpha? Tan alpha is perpendicular by base. So base equals perpendicular by tan alpha. So this radius is basically perpendicular by tan alpha. So omega 1 is V by R. Nothing else, also orbital circular motion. V, we know the linear velocity of the point circulating. So we can simply write here omega 1 is equal to V upon the radius, and radius was what? R upon tan alpha. That means you should like omega 1, you should like to write omega 1 as V tan alpha by R. There is nothing V tan alpha. This is basically V upon R by tan alpha. So tan alpha goes to the numerator and becomes B tan alpha by R, and it looks something terrible. B1 is something good, great thing. There is nothing. And omega 2 is some kind of a spin. Some kind of a spin of this, and this is rolling basically. So what is the velocity of its center? V. So it must be rotating with an angular velocity V, omega 2 equal to V by R, and that's fine. Omega 2 is nothing but omega 2 is equal to V by R. So we know now the values of omega 1 and omega 2, and omega was asked, so you can do it. So omega 1, omega 2, we got it, and you can find the rest. But there was one more thing that was asked in the problem, and it was asked what? The angular acceleration of the cone. So angular velocity of the cone is basically omega 1 plus omega 2. Omega 1 plus omega 2. That means angular acceleration beta can be written as d omega by dt equals d omega 1 by dt plus d omega 2 by dt. That's fine. And d omega 1 by dt is again 0. Because omega 1 is constant in both magnitude and direction, nobody can change it. But omega t cannot, because omega t is a vector right now in this direction, but its magnitude will remain fixed, but its direction will keep changing. Its direction is keep changing. So to find beta, we have d omega 1 by dt equals 0, and we need to find out d omega 2, and omega t is a vector whose magnitude is fixed and its direction is changing. तो इसका डायरेक्शन ओमेगा 2 का डायरेक्शन जिस रेट पर चेंज कर रहा है दैट इज ओमेगा 1. ओमेगा 2 इज इट्स ओन मैग्नीट्यूड, एंड ओमेगा 2 का डायरेक्शन जिस रेट पर चेंज कर रहा है तो चिल्ला चिल्ला के बोल रहा है कि दैट इज ओमेगा 1. सो बीटा इज द मैग्नीट्यूड ऑफ व्हाट विल बी इट्स डायरेक्शन, इट्स अ लेंथ. इसकी जगह तो ओमेगा 1 के डायरेक्शन में ही होगा बीटा का डायरेक्शन. they are asking only the magnitude of beta and this is omega 2 omega 1. दोनों का आंसर सेम है, इससे पहले वाले क्वेश्चन के और इस क्वेश्चन के भी. दैट्स फाइन एंड दैट यू शुड सॉल्व देम लाइक दिस एंड यू डोंट हैव टू वरी अबाउट दिस थिंग्स. ये मास्टर लोग हवा बना देता है अपना कोचिंग वोचिंग चलाने के लिए, कोचिंग वाला सब. बाकी सब ठीक है. थैंक यू वेरी मच.